This course is ARC 404. It's Building Information Modeling, BIM. The course is in the computation design track. I believe computation and communication. The course was offered, or the main objective of the course is to offer a comprehensive workflow for the student from the conceptual phase to the construction, let's say, phase in the project, where they will be able to learn how to model in Revit using the BIM, and as well how to run analysis and heat and cooling loads, lighting analysis, to improve their design process and to get design decisions that are more sustainable and improving the efficiency of or the energy performance of the buildings. The whole workflow was based on the McLeamy curve, which indicate, let me put the pointer here, that the typical effort done using the CAD software, where we usually put more of our time and effort in the construction document phase. It's where we extract all our documents, plans, sections, and so on. The integrated project design through BIM suggests to shift this effort from the construction document phases to the early design stages, where the ability to impact the project and the cost of these impacts are the cost is lower and the ability is higher. So being able to put more effort in the early design stages and to detect problems and to have insight on the performance of the building will give us the opportunity to improve the building and with little cost. So this is the whole idea from the concept of BIM, and we are trying to apply this in the academic course as well. I will go through the course outlines and CLOs. This is the course outlines, the planned outline and the executed outline. There was a few deletion or changing in the order of submissions, but we've ended up covering all the topics and all the materials of the course. These are the CLOs targeted. I will read them very quickly. Number one, create technically clear drawings and models illustrating assembly, materials, and architectural components appropriate for a building design. To gain insight into the building energy performance and daylight behavior. 3, assess and evaluate building energy performance and propose relevant design solutions. 4, identify and analyze possible design solutions and predict the effectiveness of implementation in the process of developing efficient design solutions. 5, extract building schedules and material takeoffs in preparation for construction cost estimate. 6, apply basic and advanced modeling toward an integrative design, complex modeling, structural system, and HVAC modeling, which will lead to an integrative design. 7, prepare project for delivery and presentation. These are how each evaluation system is targeting one of the CLOs. Okay, so we can see there was 4 project submissions and a test in the course, and how the evaluation system was hitting the CLOs. This table shows the how strongly each CLO was addressed along the course sessions. So the CLOs are up here, the sessions are in this vertical direction. We can see the orange color is where we are heavily addressing this particular CLO, all the way to the irrelevant in the gray. So we can clearly see I was hitting a lot the technical documentation and environmental system in this course. structure mainly I don't know if application or يعني demonstration considered as lectures but it was all across the semester. I was يعني demonstrating for the student always certain comments or application in the Revit. There were some assignments in the class, 3 assignments, projects, and it's one big project but subdivided into 4 phases and 1 exam. This is a learning pyramid. It's not a pyramid, but يعني mainly the biggest يعني part of the pyramid is in the demonstration section. As well يعني there was some practice by doing where I always يعني giving students in the class some time to try to figure out a certain application. So it's not always me giving the instructions. I try sometimes to let them discover by their own a certain and comments in the application. This shows the subdivision of grades. So it was evenly, مش evenly, based on the weight of each submission. The test, each phase 15%, the last phase is 30%, and they will all add it to 100%. Grades, this is the grades of the class, the final grades. We can see here the performance of the students, okay, the grades of the students and the class average in each assessment or in each evaluation system. This is a graph showing the performance of the students. We can see there is a lot of up and downs. So there is no one student who's doing everything with high grades. There is always up and downs. This table shows the grades per CLO. So it's not per assessment, it's per CLO. So we are taking the average of each CLO in the course. This, of course, led to a few graphs showing the averages of CLOs per student. So each student here, we can see how he did in each CLO. This is the opposite. It's the CLO per each student. So we can see the CLOs is in the horizontal axis. Where we can see the performance of the students within each particular CLO. So we can see CLO 2, which is B6, and had a very high performance in the class. As well, this graph shows the highest grade, the average grade, and the lowest grade in the CLOs. Given the situation of the course where I had 7 to 8 students taking the course, relying mainly on the computer lab in the university. So after the lockdown, they couldn't access the university. So they applied for an incomplete grade. These 8 students. We have 3 failing grade. We have Khalid and Aya actually couldn't, from the mid of the semester, they had maybe problems or I don't know what exactly. They applied for an incomplete grade, but unfortunately, because they didn't cover 65% of the course requirements, they are not able to apply for an incomplete grade. As well as Rana Rajab, she didn't even attend at all. Anyway, let's move on to the attendance. In the attendance, we can see this graph shows the attendance throughout the semester, and we can see a dramatic drop in the attendance level after the mid of the semester. So this is major. I will move to the subdivision because I have 3 minutes left only. The pedagogic subdivision of the course was based on 4 main phases. massing stage, schematic stage, advanced stage, and delivery stage. And between each, from one stage to another stage, the energy analysis and the performance of the building was the driver to the next stage, and we will see this in the student specimen. The main project was it was to design an elementary school, and four different sites were given in 4 different zones in the world, not in Lebanon, with 4 different, let's say, weather or climate zones to have more variation in the energy analysis and the outcome of the energy analysis. So we have a site in Spain, in Canada, in Singapore, and in USA, varying between very hot and very cold sites. In the first phase, they did a little bit site analysis, and they proposed 10 different layouts for their design, just a massing layout without any details. These layouts, like those, they put it on the software, and they run it through a special plugin called Insight, and they were able to see the different energy performance predicted by each form in this particular site. So we can see here they got numbers on the potential of the form in the energy analysis, in the energy performance. In the next phase, in the phase 2, they had to choose 3 of these the Bitcoin layouts, where they had the best energy performance in the building. And after selecting these 3, let's say 3 masses, they turned these masses into more concrete elements. So they put the windows, they put the walls, the materials, and so on, and they rerun the analysis. This gave them the ability to have more accurate results in the energy performance aspect. The Bitcoin indicator shows what Insight gave the students. So بنشوف هون, like in the north walls, the window to wall ratio, so the percentage of the window بالنسبة للwall, if they change the percentage of this ratio, how it will affect the energy performance. So we see in the northern walls there is no much هيك difference, بينما بالwestern wall بنشوف بهالexample انه there is a huge impact on the energy performance. إذا بروح لل 95% it's totally transparent, or 0% transparency. So this gave the students the ability to have a more data-driven decisions. This is example from one student. بنشوف هون بكل layout they start with $25 per meter square per year. This is the energy performance. They took a lot of decisions based on the Insight plugin, which بنشوف هون the orientation. So just by rotating the building 90 degrees, they already saved $2 in the energy consumption, and so on. We have the window to wall ratio, we have the materials, the components of the materials, and we can see there is a good بهذه الcase from 26 to 16, so saving almost 25% or 30% of the energy cost in the building. After this, in phase 3, they transformed the model into a detailed model. They did all the structural elements, all the components, the furniture layouts, the accurate openings, and so on. They were able to run lighting analysis, so they have insight on the lighting performance in the building. And they use, I think I have only 1 minute left, so I will move faster. They use the software to indicate where they have bad lighting conditions and overexposed lighting conditions. They did extract heat and cooling loads, so getting insight on the heat and cooling load performance in the building. And they used all of these to take decisions. For example, in this case, they've run the lighting analysis, and they discovered there is spots where they have bad lighting conditions, and they took design decisions to improve the lighting conditions or to reduce the overexposed lighting conditions. We can see another example here. In the fourth phase, they wrap it all together, showing their final decision and the jump in the energy performance. And we have numbers here, so from $64 to $20 per meter square per year. And we can see also the program gave them benchmark based on ASHRAE and Architecture 2030 vision, so where they stand regarding this benchmark. And these are some drawings extracted. So not only the analysis part, they did full documentation for their project, their planning, their annotations, even exploded axonometrics. And they did extract schedules and material takeoffs. I will go كمان very fast على the critical review. So despite all the difficulties and the continuous electricity and internet cutoffs, we've managed to achieve the course objectives for a large extent. Obviously there was low attendance level at the ending of the semester, and the students were mainly relying on the recorded sessions rather than going live. And we can see هون student في students يا دوب حضروا مرة مرتين بكل السمستر. الاونلاين بلاتفورم هلا اكيد الكورس كله كان tailored to be online, and the students workflow was good somehow, especially because the project workflow was interesting. التلاميذ كانوا حابين how they are doing these phases each time and running these analysis. And some recommendations, I would recommend to focus more on the energy analysis part and to reduce some of the advanced modeling requirements in the course. I can recommend to integrate more Rhino and SketchUp Revit with Revit, and to dedicate more sessions. And most importantly, I will go to this one, to have a PC that runs Revit software should be a requirement in an online teaching method, لأنه مشان ما نرجع نفوت بقصة incomplete and so on. So during online courses, they should have their own capable computers. I think أنا خلص وقتي, and I've already took 1 minute يمكن. Thank you.